Now, in this class, I'll discuss J advanced PYQs on oscillation. Right. So this is the first question. Student, this is the first question. This question asked in J advanced. Where is the pen? Yes. Student 2009. Student, this is my sixth question here. Yes, beta. This is my sixth question. Yes. So student, what is the question here? Have a look once. Beta, in this question, it's JEE Advanced 2009. Student, it's my set question here, right? Okay, fine. So student, there is a, just we'll go through your information of the questions. Yes, I remember here. XT graph. This is what, my dear? XT graph, right? So XT graph, beta, it's I hope all of you remember your sinusoidal function. It's the XT graph, right, my dear? Okay. Beta, here you can take this is 4 second. This is 8 second. 8 beta. It's 8, my dear. 8. 4, 8, and this is 12 second. Beta, you can take here time in second beta. And distance beta, you can take in centimeter. Yes, beta. Distance mentioned in the questions. That is what centimeter. Okay. XT graph of a particle under simple harmonic motion, right? As shown in the figure, acceleration of particle we wish to find. In this question, student, we wish to find acceleration at what, my dear? T is equals to 4 by 3 seconds. We wish to find this one. So, student, options is mentioned here. So you must write minus root 3 by beta 32. This is pi square centimeter square per second. Then बच्चा जी minus pi square upon 32 centimeter square per second. Option C beta. This is pi square by 32 centimeter square per second. Last student, root 3 by 32. So pi square centimeter square per second. Right. This is, I can say that of the question. It means option there. We wish to find acceleration. So this is not at 4 seconds. We wish to find acceleration more than 4 seconds here. 4 by 3. Right. So students, I can say 4 by 3 here. So yes, 1 point something beta in seconds here. You can think like that. Okay. I hope it's easy. All of you remember here. I can say A as a function of T formula. I hope student all of you remember here A as a function of T formula, right? So what is the students? A is a function of T formula here. Just tell me, anyone from all of you. Anyone from all of you, just tell me. A is a function of T formula. Okay, now I'm going to write here all the formulas which I'll use over here. So this is students in solution here. First I'm writing x as a function of T. So x as a function of T beta. This is general equation of SHM. So x is equals to A sine omega t. I'm not considering any initial phase. You can write beta g v as a function of time t. So this is what? A omega cos omega g in last beta. A as a function of time t minus A omega square This is sin omega t. I hope yeah, all of you remember. I hope Bacha Party, all of you remember here. Right. So beta for this condition, we'll go through this. Okay. Uh, so they used to find acceleration here. They used to find what? Acceleration. So Bacha ji, for this condition here, first we'll go through. I'll just first find displacement. Right, my dear? Okay. So beta ji, for displacement, what is the point? X is equals to, I hope already written here. Omega you can write beta ji. Omega you can write, this is 2 pi by t. Omega what you can say, this is 2 pi by t. Right. Okay. So first beta, I'll go through this here. So x is equals to beta. I'm using displacement equation. This is students a sine beta. Omega I'm just writing 2 pi by capital T into small t. Right. So amplitude is mentioned in this question, beta. What is the value of amplitude here? Yes, beta ji. Amplitude beta, you can take equivalent. This is mentioned +1 and this is -1. Beta both are in centimeter here. So now here student I'm going to use here a is equals to what? 1 bacha party. So x is equals to 1 into bacha. This is sine. And what is time period here? This is 8 seconds, students. So this is 2 pi by 8 into t bacha. Right. So 2 pi by 8 here. You can see 2 4 the 8. So you can write, my dear, this is 1 into beta is sine pi by 4 into t. So finally at pi by 4 you can write what? 45 degree, which is nothing but 1 by root 2. So displacement beta will get here. Displacement you can write this is 1 by root 2 times of t. Right, displacement we got. Now students, for this condition here, what we can say, just here differentiate everything. So finally beta you will go through here. You can use this result also directly. Beta for acceleration, you can use beta directly also here. So now beta I'm going to use here this result as usual. Acceleration we are interested to find. So A is equals to what beta? Acceleration is equals to minus A omega square student sine omega t. A remains 1, there is no any changes, remains 1 centimeter omega square beta. So omega you can write this is 2 pi by t and t is what beta? It's a time period. So you can write student this is 2 pi by 8. So you can say my dear here 2 pi by 8 whole square. Here what beta you can see sine here omega you can write 2 pi by 8. This timing mentioned here in the question beta. That is what 4 by 3 seconds. So you can write beta party 4 by 3 seconds here. So you can see that this is what cancel each other. So finally you can write beta this is what 4 pi square by beta ji 64 into bacha ji sine here. Sine you can say pi by 4 into bacha 4 by 3 here. So you can see easily sine pi by 4 beta how much? Sine pi by 4 beta how much here? Uh, beta pi by 4 here. Beta can you see here? This is the beta angle here. So cancel each other. So it's a angle beta entire you can treat. So this is 4 pi s square. Don't forget minus beta. Minus everywhere. Upon beta what we can say? 64. Into students, you can write 4 for cancel here. So this is sine pi by 3. 4 cancel which you can say 16 here. So you can say pi s square minus, don't forget, minus. This is root 3 by 2. So we can say, my dear, this is root 3 pi s square by 32 centimeter square per second. Any option is there? Have a look. Yes. This is option first. Beta, what we can say? Option first, beta. So this is answer of this question. This is answer of this question. So, beta, this is my set question here. It's not tough at all. Yes, beta. Literally, it's not tough at all. Okay. बच्चा जी, have a look at next questions. JEE advanced बच्चा. 2011. Yes. So, what this question, students? Again, yeah, it's very common format, my dear. Yes. Next, beta, I can say questions. This is JEE advanced student. This is 20. बच्चा जी 11. Right. So listen carefully, dear everyone. Student Jayasri Sham. Okay, fine. So next beta is the questions. Beta, in this questionnaire, what's the information? Beta, there are two equations there. A point mass is subjected to two simultaneously sinusoidal displacement function. Bacha. So you can see, my dear, this is x1 as a function of time t. This is you can not yet mention the question a sine omega t x1 बच्चा x2 as a function of time t. This is what, my dear? This is a sine बच्चा omega t plus pi by 3. A sine बच्चा what? You can say omega t plus pi by 3. Right? Okay, fine. So, बच्चा जी here just there is something changed here. It's mentioned 2 pi by 3. It's a 2 pi by 3. X1 beta, that is a sine omega t. X2 is a function of t, my dear. This is a sine omega t plus 2 pi by 3. Right. Here, I'll write once here. Again, it's a live class. It's not a physical class so that you can ask. Student a sine of omega t plus 2 pi by 3. Right. Okay. Bachaji, adding a third sinusoidal displacement function means I can say we have x1 and x2. They are adding one more. So this is x3 beta. X3 again you can take, my dear, as a function of time t. This is b sine of omega t plus pi. B sine omega t plus pi. Bacha ji, in this question, what we have to find here? Particle family at rest, bacha. So we have to find amplitude. Student, find amplitude. This amplitude here, V. V bacha in first. And second beta, we have to find here this phi angle. Easily beta I can do. Just beta think once. What is the phase difference in x1 and x2? Yes, beta. There is option here which I wanted to write. Option A, student. This is root 2a, comma beta 3 pi by 4. B, student. This is a 4 pi by 3. C, student. Root 3a 5 pi by 6. D, student, its amplitude A. This is pi by 3. Right. Listen carefully, my dear. So, what you can say for these questions? Okay. Have a look solution here, students. Beta, I'm going to rewrite this equation again, x1, x2. So, x1 as a function of time t. Student, this is a sine omega t. x2 as a function of time t. This is a sine omega t plus 2 pi by 3. So now friends, you can easily write here. Yes, beta. You can easily say what's the phase difference in these two. You can say this is A1, this is A2, and both are A only, bacha. So you have to draw student vector diagram. Yes, my dear. You have to draw beta vector diagram here. So you can say this is amplitude A, both of this. So you can write student, this is amplitude A for x1. Next beta, according to here, you can see this diagram. You can see there is a phase difference. This is what? How much? 2 pi by 3. So you can say, bacha, this is displacement remains same here, which is equals to A only, which is equals to A only, right? So student here will get here resultant of amplitude of these two vectors, these two displacement equations, right? So this angle here mentioned in this question. How much, my dear? S beta. From where are you watching, beta ji? And what's your yes, just and what's your name? Write question, beta. I'll do gravitation. I'll change the topic. Don't worry. I'll do. I'll do. Just write your name and from where are you watching? Yes. Now, bacha. So this angle mentioned here. This is from Bangalore. Okay. From which? What's your name? This is 2 pi by 3. This is what, my dear? 2 pi by 3. Okay, fine. So, beta, this is third here, third vectors. So, this is the pretty sure. You can tell. You can tell, Vachaji. This vector definitely here to balance this resultant vector because this black line is what representing. Student, this black line is representing amplitude net due to these two vectors. So here, beta, you can write. Here, beta, you can write here. This is vectors B. This is vectors B. This is what, my dear? You can say our vectors B remains as its own only. So what you can say, bacha, for this condition here, because what's in the question? Beta, that will mention the question. Particle finally is at rest. Particle finally is at rest. Right. If particle finally at rest, beta Z, so what you can say? Amplitude of B. Beta Z, you can write over here amplitude. I'll do Sagar beta. I'll do beta Sagar. Sagar, from Sagar, actually you joined from different ID today. Maybe you Sagar or someone different. Maybe someone using your name. That is also true, no? So amplitude, bacha. A particular funless is what? Completely at rest. So you can write, my dear. Amplitude of this is B. It's nothing. Student B, bacha, it's nothing here. This is amplitude of V, which is equals to A. Have a look at option first. So I can say, oh, A and C not possible at all. Student A and C not possible at all. Either B is correct and D is correct. So we have to first find what's the phase difference finally, right? So Bachaji, this is 2 pi by 3 here. So what about this angle? What about this angle here? Can I see, my dear? This is what? 4 pi by 3. This is what, my dear? 4 pi by 3 here. So this is a 4 pi by 3 amplitude A and what's the phase difference? Which is what? You can say 4 pi by 3. Correct, Nair. Because this entire angle is what? Pi only, beta. So this is beta, you can say option Bombay is correct answer. Options Bombay is correct answer. Okay, very good. So have beta. Next question here. The speed meters, agar I'll do here. Just give me some time. At least just I started here oscillations. So I wanted to do few questions here. Then I'll do. Don't worry. Okay. Next year I can say advanced 2006. Sir, I am actually from Tamil Nadu. That is a point, na? You said Bangalore, then Tamil Nadu. What is this? Beta, why you are requesting for gravitation numerical? Can you please write your concern in chat box? Yes, beta. Write your concern, bacha. I'll help you. Don't worry. I'll do, bacha. So, beta, this is the advanced question here. This is beta ji 2006. 2006. Right. Okay, come to the point. But I can see there is function mentioned here. X is equals to what, my dear? A sine square, A sine square omega t plus beta g. B, this is cos square omega t plus c plus bacha ji. Here I can't write. I'll write once again. X is equals to what, my dear? X is equals to student A sine square omega t plus B cos square omega t plus C sin omega t into cos omega t. Right? Okay, fine. Represents SHM. That is mentioned in the question. This equation represents SHM. For which options is correct? Okay. But given equations represents SHM. Student, given equation, this is represents SHM. Represents SHM. Right? So which options is correct? Right, beta. This is one more than options, beta. There is a possibility. So options A, this is A is equals to B and C is equals to 2B. Now next students, A is equals to minus B and C is equals to 2B. Option C, student, A is equals to minus B and you can say yes, beta. That is C is equals to 0. A plus B, C to B, A minus B, C to B, A minus B, which A is equals to plus B, and you can write with us C is equals to 0. So this is uh, now, bacha ji, have a look here. Last option, that is option number D. For all values of A, B, C, D, for all values, not A, B, C, D, D only, A, B, C only. For all values, for all values, value of A, B, and C, A, B, and C is student, and C not is equals to 0. C not is equals to 0. This is my idea. I can see questions here, right? They asked me this question 5 marks here. Student in JEE Bacha, they asked this question for 5 marks, right? So have a look, everyone. What question says? Okay. So Betaji, for this condition, how can we just move for solution of this question? Listen carefully, my dear. Right in solution here. Okay, what says? Student, this is just do one thing here. Right again, given equation. So x is equals to student A sine square omega t plus B cos square omega t plus C sine of omega t into cos of omega t. Right. So here the choice is multiply divide by 2 in all equations. Beta in numerator and denominator multiply divide by 2 and 2. Right. So here students I can say x is equals to what, my dear? A by 2. This is 2 sine square omega t plus student b by 2. This is students, you can say 2 cos square omega t plus beta. This is student c by 2 sine omega t into cos omega t. Right. Student, here you can say this is the simplest form here. You can simply write this is sine 2 theta. So you can write sine 2 omega t. This is what, my dear? Sine 2 omega t. Okay. This is 2 cos square theta. This is 2 sin square theta. So this is the formula beta. I hope all of you remember here. Yes, it's the formula bacha ji. Now I'm going to write further. So this is beta, there is no change. A by 2 only. 2 cos square, 2 sin square theta here. If you remember, 2 sin square theta, 1 minus cos 2 omega, 2 theta. 1 minus cos 2 theta, 2 sin square theta beta. You can write 1 minus 2 cos theta. Cos square theta, you can write 1 plus cos 2 theta. This is difference which I just keep in mind, my dear. So A by 2 square, this is A minus cos of student 2 omega t plus here b by 2. So sine is minus. Same terms you can write for cos, but it's a positive. 1 plus cos 2 omega t plus here. Plus, my dear, this is c by 2 into what, Mitsaji? Sine 2 omega t. What was the sine 2 omega t? Now, beta, just we'll go through your options. What option says? For all value of a, b, c except c not equal to 0. C not is equals to 0. Okay. So let us suppose, beta, if we will take here a is equals to 0 and b is equals to 0, then beta, what will get? Let us suppose a0 beta c b0. So you can write x is equals to what, my dear? This is c by 2 sine of 2 omega t. Now, beta, you can write near x is what? C by 2 sine 2 omega t. Okay. So, S, you can see here a sine omega t. So, this is what? Given equation belongs to equation of SHM. So, you can say, bacha, options D is correct. You can say option D is correct, my dear. Okay, next year, I'll take A is equals to B and beta what? C is equals to 2B. Then I'll see here. Because this is the final expression. So now just turn the page here. Take snapshot beta. Okay, come my dear. So what is X bacha? X is equals to already be derived here. A by 2, 1 minus cos 2 omega t plus beta p by 2, 1 plus cos 2 omega t plus here c by 2 sine 2 omega t. Right. Just keep your mind here, it's not tough at all. But literally, Vicha, your interest and dedication highly required here. Your interest and dedication has been highly required, my dear. Right. Vita, God bless you for your reaction, student. Okay. So now, Vicha, I'm going to verify here. I can see options number first. So in option first, beta, what they mention? A is equals to B and beta C is equals to 2B. A is equals to B beta and C is equals to 2B. Right. So A is equals to B here. Here beta, I'll write beta. Here beta. These two are beta. I can see them only. So beta, for this condition here, what you will get? Bacha ji, if you will say this is also V, this is also V beta. This is cancel here. So finally you will get only bacha. This is B and C is equal to B here. 2 to cancel. So you can write this is B plus B sine 2 omega t. X is what, bacha? B plus B sine 2 omega t, right? Okay. So again here you can say this is also equation of SHM. Something here, constant plus something. So again you can say, bacha, this is also belongs to equation of SHM. Beta, God bless you for your reaction. So, bacha, you can say here, options A is also correct. Very good here. Very easy question. Beta, options D also correct here. Option C also correct. Now, bacha, I'm going to take here. A is equals to minus B and C is equals to 2B. Okay. So, beta, next year I can say that is X is equals to beta A by 2, 1 minus cos 2 omega t plus beta B by 2. This is 1 plus cos 2 omega t plus beta g C by 2 sine of 2 omega t. Here beta, I'll take my dear. That is option number second here. A is equals to minus b. Student, A is equals to, I'll take minus b and C is equals to 2b. I'll take once here. Yes, correct only. A is equals to beta minus b here. So you can see over here, x is equals to beta minus b by 2. Just open the bracket beta. Minus minus plus b by 2 into beta, you can say cos 2 omega t. Here, bacha, write same thing here. So this is plus beta b by 2 plus beta. You can say b by 2, student. Uh, God bless you, beta, for your reaction here. B by 2 cos omega t plus beta. C is equals to 2b here. C is equals to 2b. Beta 2 to cancel here. So you can write over here plus b sine 2 omega t. So you can say, beta, this is finished here. This is finished. Beta, this idea, this one. So what you can say, x is equals to b plus, this is remains b bacha party. B, you can say common here. B by 2 you can take common bacha party. Cos 2 omega t. Here beta again cos here. So we can add simply. Yes, yes. Simply beta I can add here. This is what beta you can say. This is what, my dear? B cos of 2 omega t plus beta. V sine of 2 omega t. Yes, this is also SHM superposed to give a SHM equation here. So beta, this is also correct here. This is also correct, Bacha Party. Right. So you can say, my dear, options Bombay is also correct. Student, options Bombay is also correct. Last question we have here. A is equals to plus B and C is equals to 0. Okay. So last beta I'll do here. This equation. A is equals to B and C is equals to 0. So, bacha, I'll write, my dear, x is equals to A by 2, 1 minus cos of 2 omega t plus b by 2, 1 plus cos 2 omega t plus, student, this is c by 2. What, my dear? Sine of 2 omega t. Right now? Okay. Beta, take a consideration. Here A and A is equals to B and bacha C is equals to 0. Yes, beta, oscillation. Oscillation, bacha ji. Very good. So bacha, what you will get here? A and B beta equal. Then beta will get here. Just put here once. This is beta A by 2 minus A by 2, bacha. This is what? You can say, bacha party, this is cos near. Cos beta ji 2 omega t plus here. You can say A is equals to B beta. So this is B by 2. This is also B by 2. B by 2 into beta, you can say what? Cos 2 omega t plus beta g. B by 2 here. And C 0. So this is remains 0 only. So you can say, bacha, this is finished here. So this is what you can get finally. Beta x is equals to A. X is equals to A, my dear, right? So it's a constant layer. So this is not belong to equation of SHM. This is not belongs to equation of SHM. This is not belongs to what, my dear? Equation of SHM. Okay, then what's answer correct here? It's beta JEE Advanced 2006. Literally are not tough, but calculative here. I can say, being a teacher, I can say beta it's calculative here because you know how time pressure is there, and there is this pattern of question. Just write, verify the data. But yeah, all of you very smart. You can do, bacha. Beta, God bless you for your reply in live session. So beta, I can say option C is incorrect here. So what's answer for this question? America, Bombay, and Dolly. Okay. Now, Bachaji, have a look here. I can say beta for next question is yes, yes, student. Have a look at next question. Okay. Beta, this is a question that very commonly, and I discussed in classroom multiple times. And also, I pressurize to each and every candidate. Be remember this question. What's the question here? Have a look. Beta, they asked this question. Means they asked this question in what Bachaji? 1987. 1987, bacha, this is 2 marks question here. This is 2 marks question, bacha. So what question here? I'll write once. It's very easy. A particle, a particle executes, particle executes simple harmonic motion with with frequency with frequency f. The frequency, the frequency with with which with which its kinetic energy, it's a kinetic energy oscillates. Oh, student, this is a question here which I discussed in theory lecture of oscillation. Oscillates is oscillates is. So beta option first here. This is F by 2, F here. This is 2F and last year 4F. Anyone answer me this question here? I discussed this question in theory also. Anyone answer beta this question here? Anyone answer this question here? Because this is not a tough question. Anyone from all of you? Anyone from all of you? Anyone from all of you? Oh, someone correct. God bless you. Bacha, God bless you, bacha. Very happy to see you. Yes, your answer correct, my dear. Yes, beta, your answer correct here. Because this thing here I discussed in classroom multiple time, right? So particle beta just have a look here once. Yes, option C is correct. If your frequency of oscillation is F, so kinetic energy as well as potential energy twice, right? It's a simple here. How you can understand with let us suppose this is the mean position. This is the mean position. Listen here, I'm explaining this question again. So this is my dear mean position. This is my dear extreme position here, minus amplitude. This is what beta g plus amplitude here, right? So particle once you release from extreme position, so what you can write? Velocity is zero. Once you release, so what you can say? Velocity increasing and acceleration decreasing. Velocity increasing here, velocity increasing and acceleration decreasing. You can see at mean position, acceleration is what? Beta is minimum. So we can say velocity is maximum. Same thing here, Bacha. After if once you will cross mean position, so what you can say? Velocity started decreasing and acceleration is what? Increasing. So finally, beta, at this point, at if you finally arrived at left extreme positions, what you can see, velocity goes to zero. If particle finally comes over here, again you will release, then again you can write same thing. Velocity increases from left extreme to what? You can say here, mean position at velocity maximum, and acceleration is what? Decreases. If particles finally arrived at mean position, so what you can say velocity maximum and you can say what's acceleration minimum. Finally, beta, if once you will cross mean position, so what you can say, student, for this condition here, velocity decreases and acceleration increases. So you can say at the mean position, we are getting what? Potential energy maximum. Extreme position, what you can say, kinetic energy minimum. So this is the beta condition here. You can say if frequency of oscillation is F in SHM, so what about energy? That is what twice of F. That is what, my dear, twice of F here. I hope all of you understood which party. If you understood here, just write in chat box whether something here. If you understood the students, so write in chat box here. Anyone from all of you. If you literally getting at some benefit of live stream of physics points, so definitely you can write something here in the class. Anyone? Okay. How much? Just next here. Next, Betsaji. Okay. Next week, I'm going to take question here. I can say J Advanced. Student 1994. Yes, beta. Now I'm going to take your next question, which is J1994. Right. So, what is the question, student? Just go through here only. I'll write data only, picture. So, an object. Oh, someone wrote. Yes, beta. God bless you. Are correct. Yes, but I'm just trying. It's a free of cost for everyone here. I'm trying to just curate the material and content so that if you will listen at least live stream, you will get benefit, my dear. Definitely, yeah. Beta, God bless you for your reply. Now, beta, have a look at this question, beta. Pay attention here only. So this is beta. What you can say, my dear, for this condition? An object of mass. Student, an object of mass. You can write. This is zero point 0.2 kilogram, right? Executes simple harmonic motion, oscillates along x-axis with a frequency. Student, you can just take here over here frequency. This is what, my dear, executes simple harmonic motion here. Uh, yes, 25 upon pi hertz, right? Okay. At the position, student, at the position x is equals to 0.04, right? The object has a kinetic energy. At this position, object has a kinetic energy here. This is how much? zero point 0.5 joule. How much, my dear? This is zero point 0.5 joule, right? At the same point, bacha, means you can say x is equals to 0.04. So there is a potential energy here, which is what, my dear? This is zero point 0.4 joule. This is what, my dear? Zero point 0.4 joule. Okay. Yes, you need to find amplitude of SHM. They ask this question in 2 marks, students. Find amplitude of oscillation. Find amplitude of oscillation. So here, beta, this I'm going to tell you our first theory because I didn't teach theory of energy. I can say on YouTube. So first I'll discuss theory here, then I'll do this question. So beta, for energy here, you have to first write. This is first formula. U as a function of x. So beta, U as a function of x here. What you can say? Half of k x square. I hope you are all of you remember this formula. Potential energy as a function of x. X beta, you know here, what is equation of SHM? A sine omega t. Right, my dear? So you can rewrite your equation first. U as a function of x. This is half k beta. This is a square into, my dear, sine square omega t. So potential energy mentioned here for this condition. How much? 0.4 joule. I'll do it here. Next beta, just I'm going to write here. Kinetic energy as a function of x. Kinetic energy as a function of x. This is what, my dear. First, I'll write here. Kinetic energy formula half mv square. If all of you remember here, velocity of particle in SHM, v is what? Omega root of a square minus x square. Root of a square minus x square beta. So I'll put here this value over here. So kinetic energy beta g as a function of x, I can write half m beta entire whole square here. So I can say this is omega square a square minus half m omega square x square, right? So here, bacha, just do one thing here. What you can think, beta, if you remember everyone here, this condition, bacha, omega, you can write this is k upon m. Omega beta, what you can say? K upon m. So omega square beta, what you can say? Omega square, you can write k upon m. Omega is root k upon m, beta. So you can say omega square is equals to k upon m. So everywhere, beta, this thing here, just replace omega square values over here. So you can simplify, beta, further here. Kinetic energy as a function of x, my dear. So this is half, student, m here, and omega square you can write. This is k upon m into a square, bacha, minus here 1 by 2 m, bacha, by t, and omega square you can write k upon m, bacha, into x square. You can say easily, you could easily say this m finish, this m finish. So you can write it as a kinetic energy here as a function of x, half of k a square minus here half of kx square. Because at physics point here, this is literally my mean to just start live stream classes and teach on YouTube. Never I want to just give formula of any of the numerical and derivation. I wanted to just clarify the things here. How can we do further, right? So here you will get your crystal clear clarification for entire of the things, right? Okay, so beta kinetic energy is a function of x, beta. Half of k a square minus half of k x square. Bacha, here kinetic energy mentioned here, that is 0.5. So we can write, bacha, party for this condition here. Student, I'll write here once. Kinetic energy is a function of x formula because I'll use, beta, this condition only. So this is what, my dear? Half of k a square minus half of kx square. So kinetic energy mentioned here, how much? 0.04 is equals to, beta, half of k square minus here half of k, bacha, and x, beta, how much mentioned here? 0.04. Oh, I wrote wrongly. Kinetic energy here mentioned, bacha. This is zero point 0.5 joule. 0.04 whole square here. I'll write once. So 0.5 with half k, beta, I can take common here. Half k. So this is a square minus beta g. Minus beta g what? 0.04 whole square. 0.04 beta whole square here. Right. Okay. Fine. Beta, God bless you for your reply. Yes. So beta, we wish to find basically air. So now beta, they also mentioned here expression for what? I can say potential energy. Beta ji, what you can say for potential energy here. So for potential energy, beta, what is the terms here which we have to use? Which we have to use, right? And beta, you can say here for this condition. One more idea I have. I can say instead of this much calculation, beta, we have to find here total energy. So total energy, beta, what we can say? Kinetic energy plus potential energy. This is more easy for us here. This is more easy for us, beta. Kinetic energy plus what, beta, you can say? Potential energy here, right? So bacha ji, total energy equal. Kinetic energy is how much? This is 0.5 and this is, beta, plus here 0.4. So you can write total energy is equals to 0.9 joule. Acha, if we will use here this what I can say, I'll write beta here only. Here. Total energy is a function of x, and beta total energy what as a function of a party? You can say here by. So this is nothing beta. You can say here half k a square after the derivation bacha. I can write my here half k a square. Right, bacha party. This is what beta 0.9. In fact, beta this is lengthy calculation here. It's a more easiest way to do this question, bacha. So half beta and k just now I can say k beta you can write here. This is omega square into m into a square is equals to zero point 0.9 here. Everything beta known for us here. Everything beta known for us here. Right. Mass mention here. How much? 0.2 kilogram. Omega beta, the omega we can find here. Omega we can find 2 pi f. So this is omega beta 2 pi a. And f beta how much? 25. 25 by pi. इतनी पड़ गया बेटा. So omega you can write here. This is 50 radian per second. Now beta. Okay, just beta just feed it. Entire value will get amplitudes from here only. So you can write here amplitude is equals to 0.9 into 2 beta. Upper beta omega square into m here. So further beta just we calculate my dear everyone here. I'm very happy to see all of you my dear. Amplitude here. This is zero point 0.9 into 2 beta. Omega square beta. This is 50 whole square here. You can say this one 250 beta. Mass beta how much here? 0.2 kilogram. So this is finished here. These two finished beta body. So you can say amplitude square is what? 9 by 250. So we wish to find amplitude A. It's beta A square here. Beta take snapshot my dear. Student take snapshot here so that I can change. So that I can change beta A square beta. What this is you can say 9 upon 250 here. We wish to find amplitude, not A square. So we can write beta finally over here, my dear. This is what A square is equals to what beta ji? This is, you can say 9 by 250. 9 by 250. Right, beta? Okay. Here. So you can write here A square 3 into 3. Upper beta is 5 into 5 into 10 here. So we can take which A is equals to 3 by 5 root 10. A is beta what you can see 3 by 5 root 10 here. Okay. So beta A you can write here. This is what 0.6 upon root 10. Root 10 beta how much here you can write here finally. Uh, just anyone help me here? Anyone from all of you help me for further calculation? Yes, beta. Anyone help me here? Further calculation, bacha? What you will get? Anyone from all of you? Okay. So what about the answer here? Just you can solve further. You will get answer, bacha. I'm not going to solve further here. Right. Okay. So this is not a tough thing, bacha. Right. I can say it's a question here. Literally doable only. Right, na, beta? Okay. Here. Have a look, beta. Next questions here. Yes, beta. I'll do your my shift questions. Yes, beta. Now here I'm going to do my SIP question students. So this is again here. It's JE Advanced 2009 student JEE Advanced 2009. Okay, right. So bacha party for this condition here. What's the thing? It's not tough. Easy bacha. You can do here. You can do beta ji. Easy are its questions. Yes, beta. So what question says? I'll go through a diagram bacha. There is a block. There is a block. You can take m is the what? M is the mass of this block. Now, students, you can take this is the point P. There is a two spring, bacha. One end of I can say first spring here and second end beta spring out here only. Let us suppose you can say this is K1, this is K2. This is the point beta you can take P here. Mass is M. The mass M shown in the figure oscillates in simple harmonic motion with amplitude A. Right, my dear? What mentioned the questions? This mass oscillating and performing SHM with amplitude A. The amplitude of point P. Okay. Find find student amplitude of the point P is. Right, my dear? Okay, fine. Bacha ji, options here I can write. So this is option beta first here. K1 upon K2 into A. Again, I'm repeating here. This block performing a system with amplitude A. We have to find amplitude at point P. Okay, so this is first option K1 upon K2 into A. Bacha. Next here you can just say K2 by K1 into A beta ji. Next you can say K1 into A upon beta g K1 plus K2. Last option is today. That is K2 into A upon beta K1 plus K2. Again, I'm repeating here. This block is performing SHM with amplitude A. We have to find amplitude at point P. We have to find, my dear, amplitude at point P. Right. So, student, you can say here, if the spring of a spring constant, that's how you can think like that here. Bacha ji, if the spring of the spring constant cable is compressed by x1 length, just take understanding. But if this spring is compressed due to what? You can say x1 here. Then beta you can say K2 also compressed by x2, right? So what you can say? Just think beta carefully here. Got particle performing SHM here. If particle is performing SHM, bacha, so let us say if this block A means this spring compress X1. So obviously you can see in here both are in series. This block also compress same amount. I can say different amount beta. This is X1, this is different here. So K1 becomes beta compress X1 and K2 beta that is what X2. You can say this entire amplitude, you can say x1 plus x2, which is nothing but it's equals to a. It's what is equals to a only, right? So one thing here, if you remember, for series combination, this is the point here. Keep in mind for bachaji series combination here. What you can say, student, you can say k1 x1. Force remains same here. K1 x1 is equals to, my dear, K2 x2. K1 x1. Beta, this is condition. The force remains same. Beta, for series combination here. K1 x1 is equals to what, my dear? K2 x2. Simple here. Okay. So here you can write here x2. X2 beta, what you can say? K1 x1 upon K2. X2 beta, what you can say? K1 x1 upon K2 here. So let us suppose I'm calling with equations number 1 and this is what equations number 2. We wish to find amplitude here. What is the value of A? Beta, just this value here, but we can fit this x2 beta, we can fit in this equation here. So you can write x1 plus, you can say bacha, k1 x1 upon beta g k2, which is equals to A, which is equals to A, my dear, right? Okay. So here we wish to find what? We wish to find beta x1 here, right? So beta, what you can just take here consideration x1 beta, you can take common here. So what you can say? This is K1 plus K2 upon K2 is equals to A. So finally, beta will get here. X1 is equals to what we find amplitude beta. This one here, P. So beta X1 only basically. So X1 you can write bacha. X1 is equals to K2 into A upon beta G K1 plus K2. So which option is correct here? Yes, Dahlia for our green. Beta, Dahlia for our green. Yes, beta. Anyone from all of you? Okay. So this is the question here. J advanced, my shift question here. I can say beta in my shift. Paper one literally are it's not must have. Little lengthy, doable only. But this I'm telling by my own experience, my student. So I can say, but paper two are little lengthy because calculation also more question also like in-depth solution is there. In-depth, I can say concept in the question. We'll go for in-depth thinking. Then you can do. Then you can do it. So advanced wanted here. Advanced wanted here this kind of thinking right in the paper hall. Okay. Now, bacha, move here next questions. Anyone answer me from all of you this question? Okay. So yes. Are very good. Delhi evergreen here. Correct, 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 beta. Okay, bacha ji. Have a look at next question, bacha. Have a look at the next one. Question here. So, beta, I can see this beta G advanced here 2005. You can tell, sir, why you're taking usually taking. Yeah, old is gold here, right? So beta, it's J advanced bacha 2005 here. Supplementary question, or you can say beta screening question here. It's a screening question, bacha. So what's question is student? Simple pendulum has a time period T1, right? Students, you can say this is simple pendulum. Uh, Student, there is time period. Time period here you can take T1. Right. The point of suspension is now moved according to relation. So you can say in this question, not tough at all. You can do easily. By as a function of time t beta. What you can say, by is equals to kt square. Y is equals to kt square. K beta you can take 1 meter per second. Mentioned in the question, students itself. Okay, where why is the vertical displacement? Why is the what vertical? You understood here. Why is now D means displacement equation only. Okay. Now time period becomes T2. Means initially beta particle has a time period T1. Because of this displacement relation, time period now, student, this is the time period becomes T2. So we have to find here. We have to find ratio of. We have to find the ratio of student T1 square upon T2 square is option here. I'm going to write this is first beta G 5 by 6, next beta G 6 by 5, 1 and last beta this is 4 by 5. Last student that is 4 by 5 here. So have a look at party this question. It's not a tough at all. But at least here you can just pay little attention over here. Okay, so now student, I'm going to solve this question here. Activity on the class only. Right. So solution here. Just go through this. Y as a function of g, kt square. I hope all of you remember here. Displacement equation if we have from kinematics, you can also say if we have a displacement equation, you will differentiate on time with respect to means one time differentiate here with respect to time. What will get velocity of particle? What we will get velocity of particle here. So you can see this one. Velocity is equals to which I can write d by dt. It's nothing here. You can say 2 kt. You can say, my dear, this is the 2 ktr. Okay, differentiate again here. Then what will get? Acceleration. So this is, you can say d2 by dt square. It's nothing here. You can say this is 2k. Means acceleration we are getting constant. Acceleration we are getting constant. Okay, and k beta how much mentioned here? 1 meter per second square. So you can write, my dear, acceleration is equals to 2 meter per second square. Acceleration is what, my dear? 2 meter per second square here. Okay, fine. But Chaji, if you remember here, time period of simple pendulum. Yes, but I can take care. This is step one for this question. Now, student, I'm going to just solve a further step of this question. This is what, my dear, step two here. This is what, my dear, step two here. Okay, fine. So, beta, for this condition, I'm going to use beta formula of time period of simple pendulum. So, this is nothing, student. You can say 2 pi under root L by G. 2 pi under root L by G. Right. So beta for the case of T1 here, what says a simple pendulum has a time period T1. The point of suspension is now moved away according to relation. Okay. So initially beta I can say at T1 there is no issue at all. Right. So T2 beta what we can write? This is 2 pi under root L by this is what A plus GR. This is what, my dear? A plus GR. Okay, fine. So here, bacha, I can say for this condition here, this is T2, bacha. 2 pi, bacha. This is L squared A plus GR. A is what? 2 we got here. And G beta, what will take here? G beta, what will take? Uh, we'll see. We'll see later, beta. Okay. Just let us do a square bit. Let us suppose this is equation 1 student, equations 2. Beta equation 1 here. Just do a square and just add this, divide these two. So T1 square upon beta is T2 square. Square beta entire here. So you can say 4 pi square L upon G. Student here again you can write here 4 pi square. This is L upon 2 plus G. This is beta terms here. We can say cancel. Right. This L beta finish here. So what you can write, student, finally, T1 square upon T2 square is equals to 2 plus G upon GR. So G beta values, you can take 10. The G value beta you can take 10 here. In fact, 10 mentioned in the question, students. 10 mentioned beta in the question, students. G you can take beta 10 meter per second square here. So you can say T1 square upon beta T2 square here. So this is 2 plus 10 here, 12 by 10. So you can say 2 times no? 6 by 5. Yes, beta. So this is answer of this question here, 6 by 5. Have a look in the option is there. Yes, here. Bombay. Bombay option is here, beta. This is option beta. What you can say? This is the Bombay. This is what, my dear? Bombay options here. So I can see questions driven on here. Little attention required. Little attention required here. Little attention required. Beta. Yes, beta. Little attention required, bacha party. Right. So have a bacha party next year. Next question, student. Okay. It's again here. I can say J advanced screening questions. It's what, my dear? J advanced screening questions here. Uh, correct, beta. Correct here. But what's the meaning of secret? You wrote. Okay. Now, students, I can say next year. This is J advanced bacha 2004 year screening question, right? So again here we'll go through diagram only. We don't have a much time here. So this is a diagram which been mentioned in the questions here, right? So this is it's P students. There is a block here. You can say this is Q. This block student basically connected, yes, beta, with the help of spring here. And this is fixed. Yes, beta. This entire setup here, you can say this is what remains fixed. Right. There is a friction here. You can take in consideration also. There is a frictions, my dear. It's nothing here. It's a mu s. It's what beta? You can say mu s here. Right. For these questions. A block P of mass m, beta. You can take mass of block P, which is equals to m. A block of mass P is placed on a horizontal frictionless plane. A second block of same mass. You can say that mass of Q block is also remains m only. Both are beta same here. Identical mass m and n. M and m bacha party. Right. Okay. Second block of a same mass m is placed on it and is connected to spring constant K. You can take which a spring constant of spring. This is what K. You can take in consideration like this. Okay. Uh, the blocks are pulled by a distance A. You can take bacha. Block A is what? Pulled at a distance capital A beta means amplitude you can take. Block Q oscillates without slipping. Okay, there is no slipping at all. Block Q is oscillating. Let us suppose if we'll give a, I can say there is what little air pulled by a distance A, then block Q oscillates without slipping. What is the maximum value of friction force between the two blocks? Okay, we have to find here. Uh, find find maximum value of find maximum value of friction force. Maximum value of what, my dear? Frictional force here. Okay, options here I can write K A by 2, my dear. Next here, this is K A, option C beta, mu S into mg, and last student, 0. Again, I'll repeat here the questions. This question asked beta in JEE Advanced 2004 year screening. There is a setup in front of you only. There is two block P and Q, both are identical in mass. There is a little, you can say, if you pulled the block, I can say pull the blocks at a distance A. So what I can say block Q is what? Performing oscillation without slipping. So what is the maximum value of frictional force over here? This is the question. This is the question which we need to understand and into. Okay. Bacha party, have a look here for the solutions. Student, have a look at solution of this question. What says? Bacha, here acceleration is same because here we are applying same push. So acceleration is same for both P and Q. As the block Q oscillates but does not slip, then P minus Q system beta because they are oscillating but they are not slipping. So beta for this condition here, what we can write? It is spring constant by A. Spring constant beta, I can say because if there is oscillation here, if there is oscillation, so definitely you can say, you can predict. So there is what? Little stretched. There is what? Little expansion. In the what? You can say bacha body for spring here. Right. So you can write angular frequency. You can write with what? Angular frequency here. So if there is a little stretch bacha, so you can write angular frequency, that is what omega. I hope all of you remember here. K upon what beta? There are two mass here and both are identical. M plus M only. So you can write angular frequency. It's nothing but K upon 2M. Omega beta, what you can see? K upon 2M. We wish to find maximum frictional force here. So first we have to find what is the maximum acceleration. So I hope all of you remember here acceleration maximum at with what you can say. This is A omega square. This is all part of derivation here. Just keep in your mind. A bacha body you can say omega square here. Omega beta we can write here. This thing already we found. So student finally you can write acceleration maximum. It's A only bacha. What's here? I can say omega square. Beta what we can say omega square here. So bacha I can say for entire terms square bacha party. What you can say K upon 2M. So A maximum you can write beta. This is K upon 2M. Beta the amplitude maximum you can write beta. This is Ka upon 2M. Right. So acceleration to the lower block is provided by the friction. Acceleration of this block can get from friction only. That is for sure. Right. So maximum force, what we can write? Maximum frictional force. That is a question, Bachcha Bhatti. So frictional force maximum. This is what, my dear? You can see in here, M into A maximum, M into A maximum beta G. So this is simply we can write M into beta. This is K A upon 2M. MM cancel here. So you can write frictional force maximum, which is nothing but you can say Ka by 2. What, my dear? You can say this is Ka by 2 here. Any option is there? Yes, here. I can say America. Yes, yeah. You can say America is correct answer for this question. Yes, beta. You can see what America is a correct answer for this question here. Okay. Have a look at the party. Next question here. Yes. Did you take snapshot here? Yes, beta. You can take a snapshot. Okay. Bacha party. So what's the next question? Which question I have to do here? For here? Okay. Come here. I can say, bacha, just do a few questions. These kind of questions you can do easily. These kind of questions, bacha, you can do easily here. Very much. Okay. So I can say, bacha, you can do here one more questions of this. Advanced 2023 here. It's a good question, bacha. Yes. Beta, have a look at next question. So this is my dear. This is JEE Advanced 2023. What, my dear? JEE Advanced 2023 here. Have a look at these questions. Okay. So what questions is here? 2 point like objects of masses 30 gram and 20 gram are fixed at the two ends of rigid massless rod. Okay. I'll read the question, bacha, and I'll make diagram here. 2 point masses. You can take, bacha. There is a rod. Already mentioned in these questions. This is the rod, my dear. Right. And there is two masses here. You can say beta, one mass is, my dear, this is 30 gram. Another mass is you can take, bacha, this is 20 gram. One is 30 gram, other is what, beta? You can see 20 gram. Okay. 2 point like objects of masses 20 gram and 30 gram are fixed at the two ends of a rigid massless rod of a length 10 centimeter. Okay. You can take, my dear, L is the length of rod, which is equals to 10 centimeter. Right. Okay. Someone answer. Yes, yes, correct, correct, correct. Correct, beta ji. Very good here. Dear meter, the system is suspended vertically from a rigid ceiling using a thin wire. Okay. I can see, beta, this is a finally rigid. This is what, my dear? Finally, yeah, rigid from here only. Yes, beta. Yes, beta. So this is a rigid, finally from ceiling. Okay. Now, beta, what's in the questions here? I can say using a thin wire attached to its center of mass, as beta center of mass, as shown in the figure. The resulting torsional pendulum undergoes small oscillation. Okay, there is small oscillation here, torsional pendulum. Just these all are, I can say, killer point for the to solve the questions here. This is what, my dear, you can see killer point to solve the questions here. Okay, now beta, due to gravity here, always Earth gravity acting. This is mentioned in the question as well, right, my dear? Okay. So the resulting torsional pendulum undergoes a small oscillation. The torsional constant. Okay, beta, this is things they mentioned here. Torsional constant. Students, torsional constant here. You can see C. C is mentioned, student. This is 1.2 into 10 to the power minus 8, my dear, Newton meter per radian. This is beta C at torque constant. If you remember na, torque is equals to C theta. Now it's because if you use here this result beta, torque is equals to C theta here. So you can beta think like this. This is what C is equals to 1.2 10 to the power minus 8 Newton meter radian. Newton meter radian. Right. Okay. Now what's about it? You can see this further. What you can see. Beta G for this question here. Just we'll go through this. Okay. The angular frequency of oscillation we have to find. Very good here. Find angular frequency. Beta C, we have to find here angular frequency. It's a integer type questions, my dear. There is mentioned here n into 10 to the power minus 3. This is radian per second. This is what, my dear? Radian per second. Okay. Hello, Komal beta. How are you? From where are you watching? Okay. Now, bacha. So we have to find here the value of n. We have to find what? The value of n here. Okay. So come to the point here. You can do this question. Already I gave you the formula. You can do, my dear, easily. Okay. So bacha, there is what? This is beta, you can say formula of torque you can use for. I can say uh, beta, if you are not, okay, there is this is let's suppose this is a pen, right? So here you can see not possible at all. You can take care those body. You can take like a cotton cloth or any cloth, right now. You can take, yes, yes, I can use this one. I can use this one here for understanding. Okay. In fact, I can't say. Okay. Yes, beta. You can use here. So what you think here? You can see finally. We can just rotate like this much only. We can rotate this much only, right? So this is nothing here. You can say what? It's a torsional constraints. Beta, what you can see it's a now just you can leave here. Though now particle what again come back on a initial condition. Beta particle what again come back beta what we can say initial condition here. So how much you can say tendency of this I can say thread, how much tendency of this thread I can say we can twist. So that is nothing here. It's you can say what? Torsional constant. This is what beta we can say torsional constant here. Okay, come to the point. So, but certainly for this condition here, we'll go through these solutions. I can see these are the theory point which I said, right? So, but certainly for this condition here, for torsional constant, what is omega we can write? Beta omega beta for this condition here, we can write C upon I. C upon I. So simply we can write here time period. This is, I hope all of you remember here. I repeated multiple times in same lecture today only beta during discussion here. 2 pi by omega. So this is what beta you can see here 2 pi by and omega beta what you can say a root of C upon I, right? So time period you can write with 2 pi root under I by C. 2 pi rooted under I by C here. I is nothing here. It's a moment of inertia. I'll beta solve here only here. Beta, this is step one here. I is nothing, my dear. This is what you can say moment of inertia. Okay, fine. So here for moment of inertia, it's with a midpoint. So I can tell you, take bacha. This is the 5 centimeter. This is the 5 centimeter, right? So what is mass is mentioned here, right, beta? You can say bacha party because here we can also find here. You can see, sir, how can we say 5 centimeter? Both are not identical mass. It's not. I can say true, sir. You correct, beta. You can't say like that here. It's midpoint. Three midpoint. It's a true, but you can't say it's this body also 5 centimeter. This body also 5 centimeter. Oh, so you can say, sir, this is first thing we have to must know. How can we find this much? So, beta, I'll discuss here only further questions. Right. So this is, I can say, a task for all candidates. How can you know what is the masses of this? How to find? So this is Vacha party. You can say which are the 30 centimeter, 30 gram here. It's not. It's mass here. Now, dear, this is 20 gram. But I don't know na. Then you just call once two particle system formula. I taught here in center of mass. You can tell, my dear, R1. This is, my dear, you can take R2. It's a short trick here I give in the classroom. It's a short trick, my dear, I give in the classroom here. So what about R1 here? For getting R1 with Charvati, just forget this much here. You can take better. Let us suppose I'm calling M1. This is what? M2 bacha ji. So R1 beta what you can say? R1 bacha bati, you can write M2 into R upon beta M1 plus M2. So R1 bacha M1 is M2 is 20 gram, 20 beta. And R beta how much? 10 centimeter here. And M1 plus M2 beta. This is what? You can say 50. So you can see here one cancel which is G. So R1 beta, you will get this is 4 centimeter. So beta R1 beta, what you will get here? R1 bacha party, my dear, R1 you can write 5 centimeter. Yes, beta. R1 bacha, you can say this is now beta. Okay. R1 beta, what will got here? uh, 4 centimeter. Simply beta, you need to find here R2. Formula is literally very important, bacha, for advanced here or any competitive examination. Formula is a superhero here. So R2 beta, what you can say? R2 beta G. If you are finding R2, then you have to forget M2. So here beta, M1 into R. Upper beta, you can say M1 plus M2 here. So M1 beta 30 here. So you can write, my dear, R2 is equals to beta, God bless you. Next year I can say R2 beta. M1 beta how much here? This is 30 gram. Okay, so this is 30 into beta Z 10 upon beta Z 50 here. Again, this can say okay. So R2 student will get R2 beta, I can get what? This is a 6 centimeter. It's a 2 near lighter body here. Beta, center of mass, I can say inclined beta. Center of mass, you can say towards Vajra party, basically heavier body here. So this is beta 4, beta R1 is what it is? It's a 4 centimeter. And R2 beta G, this is 6 centimeter. Beta, God bless you for direction. Okay, someone wrote. Clear, sir. Thank you, sir. Oh, beta, God bless you. No, yeah, it's a physics point. You know, everyone. Physics point here. I'm going to just avail always here curate solutions of any question. We can I can just take easily 4 and 6, but no, it's not worth here for the students. That's why here you can just keep following BK sir. That highly required here. If you want to become IHGN, an IHGN, or any, if you want to go for any competitive examination, keep following BK sir. That is highly required. Okay, bacha. R1 have to be got here. Mm, beta, God bless you for your reply. Yes, bacha. Next year, next question here. Have a look, bacha party. Next question here. Oh, we have to just complete first. Na? We have to first find moment of inertia. I. Just we got here this one. Bacha. So we can get here IR. So I is what? Which M into R square. So beta M is what this here, and R is what? Beta we can say 4 centimeter. Beta what we can say 4 centimeter here. And this is 20 bacha, and this is what? R we can take from what? You can say bacha axis of rotation here. So this point is what? Axis of rotation bacha party. So yeah, first I'll find beta I on next slide here. Take beta snapshot. Hmm. So now friend, I'm going to find here I. So I bacha this is you can say M1 R1 square plus beta M2 R2 square. So M1 which this is 30, R1 beta G 4 whole square, M2 beta G 20 into beta G 6 whole square here. So I beta how much will get? 30 beta 4 4 ja 16 student plus 20 into 36. So we can say I is equals to this is 480 plus beta 720 here. So this is beta I can say 8 1200. I you can write, my dear, 1200. This is gram centimeter square. We got IR. Then what's the big deal there? We can easily get Vasachi what? omega here. So omega you can write, bacha. This is I by c beta omega. Omega is no. What is omega? C by I in here. It's a c by I. So you can see, bacha. This is c and this is I here. C already mentioned in the question, bacha. So omega beta c how much here? 1.2 1.2 10 to the power minus 8 beta, and I are just we found this is 1200. This is 1200. But be careful here. What's the unit of this one? Yes, beta. There is unit Newton meter per radian. So beta, we have to convert here these entire things in SI only. So beta, gram here, what you can see? 1 gram. 1 gram beta, what you can see? Tell me. 1 gram beta, what you can see here? This is 10 to the power minus 3 and centimeter square here. You can say 10 to the power minus 4 meter square, right? This is a condition beta for omega here. We used to find, but this was only here. You can see 4 plus 3, 7 here. B goes up beta, so positive only. So omega beta, we can write here 1.2 into 10 to the power minus 8 plus 7 upon beta 1200. Beta, just take here 10 over here. So you can write, my dear, omega. You can write, my dear, omega, which is equals to what, my dear? This is 12 upon beta, 12 into, this is plus 3 beta. So you can say this is minus 1 and minus 3 or minus 4. This is cancelled with separate. So what you can say, this is 10 to the power minus 2 into 1. 10 to the power minus 2 into 1, right, beta? Okay, omega to the power minus 4 near. So, yes, 10 to the power minus omega beta will get 10 to the power minus 2. What's it? You just go to your options. What's option says? Okay, then beta we have to multiply divide by 10 and 10. No? Omega beta, this is we got here. So answer in terms of 3 here. So what you can do in another paper, student? Omega we got, this is 10 to the power minus 2. Just multiply divide by 10 and 10. So omega will get here. This is 10 into 10 to the power minus 3 radian per second. So what is n here? Because we wish to find n only. N is equals to 10. It's advanced questions here. Right? It's advanced question, bacha. But we can say omega n is equals to 10 bacha party. So this is there this much for today class. Right? I'll discuss later bacha party next coming all questions here. Right? So I can say bacha party everyone. Just stay at home here. Do hard work. Yes, beta. It's highly required, bacha. It's highly required, bacha party, right? Okay, now students, I'm going to just stop your class, beta. Take snapshot. Wish you all the best. Keep following BK sir. Okay. So this is all about beta. I can see today class. Okay, Jai Shri Sham. Thank you. Oh, beta. God bless you. Jai Shri Sham.